Okay, so this example is from the book by Rao, and actually there's a story behind this example. That is like they try to optimize their profit, okay, based on the constraints. Yeah, like the hours or the number of people they have. Okay. Anyways, if you are interested, you can read the book written by Rao and understand the story behind this example. But over here, let's just simply solve the problem. Okay. So we want to minimize f. Over here, it's a 3-variable problem. Yep. Okay. So we have this minimization problem. Again, this is about like if you take a look at the example in the book, Rao, maybe I should write it down. Okay. So from the book. Written by Professor Rao S.S. Okay. Good. And then let's try to solve this using KKT conditions. Of course, you can also solve the same problem using the first method, right? The transformation method. But over here, since we have just learned the KKT conditions, let's solve this problem using the KKT conditions. Okay. And the first thing is, it's always better to transform the problem into the standard form. Right now, what do we have? Yeah, it's minimization. Yeah, so that's fine. Oh, by the way, if it's a maximization problem, you need to multiply the objective function by -1 to make it become a minimization problem. But now it's a minimization problem, so that's fine. However, for the constraints, over here we have greater than or equal to constraints. That's not that good. Okay, so it's better to transform them into the standard form. Okay, so yeah, let's say over here. So let's just define G1 equals 15 minus x1. Okay, right, in this way, the constraints becomes this kind of standard form. Okay. Less than or equal to 0 for the non-negative constraints. Okay. And G3 equals 150 minus. Less than or equal to 0. Okay, so with this kind of, maybe I should write it down over here because. G3 150. Okay, so yeah, these are the 3 constraints, and then let's just start with using the KKT conditions. Okay. Okay, so a lot of conditions. Okay. First of all, we take the partial derivative with respect to xi. Okay. Over here, there are 3 constraints. Okay. Wait, I still think it's better to define L first. Yeah. So let's say over here, let's say L is what? L is F plus the summation of lambda G. Okay, so L equals F plus lambda 1 G1, lambda 2 G2, lambda 3 G3. Oh, I just heard that the professor over there is talking about whether the possible case was using that classroom or not. Okay. Anyways. Yeah. Okay. So maybe I should also say that if you are about like 1 meter, if the distance between you and your classmates are if the distance is within 1 meter, maybe it's still better to wear the mask. OK， 好了，还是提醒大家一下，如果距离1公尺之内，可能还是要戴口罩比较好。我现在跟大家距离有2公尺，应该还 OK。OK， so L is that. And then let's just take the partial derivative, okay, with respect to x1, okay, and of course that's partial derivative with respect to f and I mean take partial derivative for f and also for g1, g2, g3, okay. So I'll just say this is 0, okay, and over here, let's just directly write down the equation, okay. Yeah. To save time, let me directly write down what this is. Okay, so that's the first equation. And then partial derivative with respect to x2 equals 0. And we can have the second equation. 2x2 plus 20. Okay, so and then take the derivative with respect to x3. We will have the third equation. Okay. And so that part is finished. Okay, taking partial derivative with respect to x. And then we have lambda g equals 0. Right now we have 3 equations. So it's a little bit tedious, okay? So we have 3 constraints. So there are 3 equations for lambda g equals 0. So lambda 1 g1 equals 0. And lambda 3 g3 equals 0. And of course, we can write it down like this. So lambda 1 g1 lambda 2 times G2 and lambda 3 times G3 okay, so that's the second part, right? Lambda G equals 0 and then the next just G being non-negative. Yeah, that's very easy, so let's just simply write it down, okay? So that's, of course. Okay, and finally, lambda 1, lambda 2, lambda 3 they are all non-negative, okay? Lambda 2, lambda 3. Okay, yep, so it's really a pain, right? We have so many. But the thing is, what we do is to solve for x and lambdas using the first 2 sets of equations. Because of the 0 signs, right, we are able to solve. And then when we have some solutions, we will need to come back here and check whether those conditions, like non-negative or non-positive constraints for the lambdas, okay, whether those constraints are satisfied, okay, 可以吗？我们用等于的这个部分先解，解完之后，然后再带到 G1、G2、G3 还有 lambda 这些来确认，看是不是合理，是不是正确 ，OK? Yep. So let's start. And do you guys remember my said that usually when we solve the set of equations, usually we start with what? Something times another, right? So usually we start with equations like these, and because the first one looks the simplest, let's start from this one, okay? So let's say this is equation 1, 2, 3, 4, 5, and 6, okay? Let's start from the equation 4, okay? That is lambda 1 times 50 minus x1 equals 0, okay? So, again, we will have two cases, right? So equation 4, that is lambda 1 50 minus x1 equals 0, and we can have two cases. So case 1 is what? Case 1, lambda 1 equals 0. And of course case 2 is like 50 minus x1 equals 0. But anyway, yeah, let's first have case 1. So when lambda 1 equals 0, we know that equation 1 now becomes 2x1 plus 40 minus lambda 2 minus lambda 3 equals 0, and equation 2 yeah. Okay, so this is equal to 0, and over here we can solve for x1, okay? So in this case, equation 1 becomes that, so x1 equals minus 20, okay? So in this way, x1 can be solved, and then for equation 2, we can directly solve for x2, okay? So x2 equals 1/2 lambda 2 minus 10, right? Okay, yep. And from equation 3, yeah, it's even easier, okay? So x3 can be solved directly like that. Okay. So in this way, x1 and x2 and x3 are solved in terms of lambdas, okay? So equation 5 and 6 can be rewritten, okay? So equation 5, I'll just say 5. So equation 5 becomes what? Okay, if we plug in x1 and x2, okay, let me directly write it down. 100 plus 30 minus x2 minus x3 equals 0, and 6 is lambda 3 Okay, so that's the two equations from equation 5 and equation 6. Okay. So again, you see, now we have something times another, which means that we will have like 4 different cases, right? So let's say this is case, yeah, so this is like case 1.1, okay. So case 1.1, yeah, let's say both lambda 2 and lambda 3 are zeros, okay? So that's case 1.1, and of course you can imagine case 1.2 is what? Is like lambda 2 equals 0 and 180 minus lambda 2 minus this times lambda 3 equals 0, right? And something like that. Well, let's start with case 1.1. Okay? 因为我们有这两个 equation 要解的话，就是要么 lambda 2跟 lambda 3都等于0，然后另外这两个不等于0。OK. So anyways, let's try to solve for this. Okay. So if lambda 2 equals if both lambda 2 and lambda 3 equals 0, what do we have? Yeah, in this case, what is x2? x2 equals what? Both lambda 2 and lambda 3 are zeros, so x2 equals negative 10. Okay. And what is x1? x1 equals negative 20, right? And x3 equals 0. Okay, so this is what we have. But the constraints, let's take a look. You see? Let's just take a look at the first constraint, G1. Okay. 50 minus x1. What is x1? x1 is negative 20. Okay. So 50 minus negative 20 is larger than 0. So the first constraint is violated, which is not good. And how about the second constraint? 100 minus x1 minus x2. That's still greater than 0. So the second constraint is violated. Okay. So anyways, if you see one constraint violation, it means that this is no good. Okay. So there is some constraint violation. Okay. So there is constraint violation. Okay, which means that we need to eliminate this possibility. 可以吗？反正就是刚刚说了，我们用这个等于符号的先解，可能有好几组不同的解。那现在解出来的第一个情况是像这样 ，OK。然后你就带回到底下的这一些 constraint， 不管是 G 或者 lambda， 然后发现只要其中一个有违反的话，就要它就不行 ，OK。Okay, so case 1.1, is bad. Okay, case 1.2, and what we will have is this. Okay. So because lambda 2 equals 0, in this way we can see that lambda 3 becomes 120. Okay. And now let's go back and take a look at lambda and see what x1 and x2 and x3 is. So let me quickly show you. So x1 is what? 60 minus 20 equals 40, right? I think you can just solve this by yourself. Okay, let me directly write it down. So x2 equals 50 and x3 equals 60, okay? But again, some constraints are violated, right? Because as you can see, x1 equals 40, G1, 50 minus 40 is 10. That is not less than 0. So, again, there is constraint violation. Okay, which means that this is, again, no good, okay? And you will see that case 1.3. Very similarly, case 1.3, let's say we have lambda 3, case 1.3 is 130 minus lambda 2 minus lambda 3 equals 0, and lambda 3 equals 0, okay? And case 1.4 is what? So 130 minus lambda 2 minus lambda 3 equals 0, and 180 minus lambda 2 minus this equals 0, okay? So very similarly, after solving them, okay, and plugging back into the constraints, you will see that there is always some constraint violation, okay, for case 1.3 and case 1.4, okay, so the whole case 1 just doesn't work, okay? 可以吗？你等一下你自己就试着做一下，因为真的我有试过，都解出来， 反正就是当 lambda 等于0，它虽然有好几个不同的 case， 但是每一个 case 最后的都会违反根式。Okay, so we have to delete those possibilities. Okay, and then let's just take a look at case 2. So case 1 lambda equals 0. Okay, and case 2. Case 2 is what? Is 50 minus x1 equals 0. That is x1 equals 50. Okay. So case 2 is that 50 minus x1 equals 0, or x1 equals 50. And in this case, let's see, what can we have? Okay. So, from that, if we just directly look at equation 3, so equation 3, now we see that x3 equals lambda 3, no, yeah, lambda 3 equals 2x3, so that's equation 3. Let's substitute. Equation 2, okay? And in this way we have lambda 2 equals 2x2 minus 2x3 plus 20, okay? So that's lambda 2, okay? And equation 1. So in this way, equation 1, what is equation 1? Okay. So in this case, equation 1 can also be expressed in terms of, lambda 1 can be expressed as x1, x2, and x3. Okay, so equation 1, lambda 1 is what? 2x1 plus 40 minus lambda 2 minus lambda 3. And because right now, lambda 3 equals 2x3, lambda 2 equals that. Okay, so lambda 1 can also be expressed as a function of x1, x2, and x3. Okay, so finally, lambda 1 can be simplified as this. Okay, yep. With this kind of substitution, and then equation 5 and equation 6 can be rewritten. Okay, so equation 5 and equation 6. Yes, equation 5 and equation 6. Okay, equation 6, lambda 3 times that. Okay, so as you can see again, there are 4 cases, right? So, let's say case 2.1, okay? Case 2.1, both lambda 2 and lambda 3 are zeros, okay? And if both lambda if both of them are zeros, then you can just continue with with solving the problem. But I don't think I need to solve everything for you guys, right? Yeah, you can just, because this example is from the book, you can just read the book and see the whole thing, okay? Yeah, so you can just perform the calculation, okay? Yeah. Case, of course, there are 4 cases, right? Case 2.4, totally the 4 cases, and let me just give you guys the final solution, okay? So finally, what we have is this, x1 equals, they are all lambda 1 equals lambda 2 equals 20 and lambda 3 equals 100. Okay, so that's the final solution. But of course, you need to have several cases, okay? And then solve for each case and also check whether the constraints are violated or not, okay? And finally, yeah, that's what we have. OK 嘛，反正就是这边也是跟刚才类似哦，你不同的 case 要去解，然后再带回确认它的 constraint 是 OK 的，然后最后终于找到哦，总算找到会有一组是带进去是都 OK 啊，反正这是就是最后这一题解。Yeah, I know it's a little bit tedious, but yeah, but it's just because over here we have three variables and 3 equations. That's why it's a little bit tedious, but it's a good practice, okay? Yeah. So, any question? Yeah? Okay. Are you alright? Oh, and by the way, in homework 1, some problems are created by myself, but some problems, at least one problem is from the book by Rao, and there's also one problem from the book by Schneemann. Okay, do you guys know why I want to do this? Because I hope at least you will have a chance to open the book, okay, or to read, or to know what's going on inside of the book, okay? Not just understanding what I talk over here. Although it is actually fine if you just want to understand what's going on over here, I still think it is better if you can have a chance to read the books, okay? 可以吗？所以我在那个 homework 里面，我的其中有一题是从 Rao 这本书，还有另外一题是从 Schneemann 那本书出来的 ，OK？Yep。Okay. So, yeah. Let's see. You know, I think I will talk more theories next time. And today, my focus will be letting you guys be able to solve the homework problems. So let me quickly finish the third method for solving the problems with inequality constraints. Okay. Oh wait, do we have time for that? Maybe. Okay, now I guess this is fine. Okay. Okay. So let's come back over here. Okay. So method 3. Oh, by the way, maybe you are wondering how come we want to learn several different methods. Is it okay if I just learn one method? Yeah, basically. Okay, especially KKT condition. Yeah, KKT conditions. Yeah, it's pretty it's a very complete set. Okay, so maybe that's fine. However, the reason for learning method 3 is because the understanding of the so-called duality theorem is pretty important. Okay, and that's why I still think it's good. It's very good to learn method 3. Okay. So let's see. For method 3. Okay. Yeah, that is using the so-called duality and the so-called saddle point theory. Okay. Okay. Yep. But before introducing the method for solving the problem, let's quickly review what we mean by a saddle point. Okay, I think last time we talked a little bit about the saddle point, right? But today, let me give you guys this mathematical definition. Okay, so a saddle point. Yeah. The saddle point is basically defined like that. Okay. For x satisfying this condition, that is x minus x star less than epsilon, and of course epsilon is a small positive number. Okay. And for lambda satisfying this lambda minus lambda star being less than epsilon. Okay. Anyways, it means that like within the vicinity, like that is near the point x star and lambda star, the equation f of x star lambda less than f of x star lambda star less than f of x lambda star, the equation holds, or this equation is true. Okay, so this is the so-called saddle point if this kind of condition is satisfied. That is, for x and lambda near x star and lambda star, then this kind of inequality is true, or holds. So what does this mean? I think last week we already said that it's just like if you take a look, if you look at the function from one point of view, it's a local minimum. But if you look at the same function from another point of view, then it's a local maximum. Okay? And if you take a look at this, basically, that's exactly what I said, right? 可以吗？就是你从某一个方向来看，它好像是一个 local minimum， 然后再从另外一个方向来看，它是一个 local maximum。但数学上的话，其实就是当你变动某一个 variable 的时候，它是 local minimum， 但是当你变动另外一个 variable 的时候，它却是一个 local maximum。Okay, so let's take a look at. How about taking a look at this part? Okay, if we look at the right side, not the right side, I mean the right two, the right, the two functions over here, okay? Don't you think it just means that x star is a local minimum, right? Because for other x, x star is less than f of x star is less than f of x. Okay, and over here we just assume that lambda doesn't change. Yes, yeah, lambda doesn't change. Okay, because lambda is lambda star over here. So if lambda is fixed, then when we vary x, we can find that f of x star corresponds to the local minimum, right? Okay, so that's for this part. But how about for the other side? Over here, can you see that? If x is fixed, that is, if x is fixed at x star, then when we move lambda, we will see that lambda star corresponds to a local maximum, right? Lambda star is larger than that. Okay, so f of lambda star corresponds with a local maximum. Okay, so great. Yep. And if this is true, it just means that x star, the position, so the position, the saddle point, that is the position x star lambda star. Okay, over here, this is the saddle point. Okay, any question? So that's the so-called saddle point. And then you may want to ask, so why do we need to know this? The thing is, it's very interesting. That is, basically we need to solve, most of the time we solve a minimization problem, right? But when we have the constraints, and then when we try to consider the constraint and build the so-called Lagrange function, then we can try to solve the same problem from a different perspective. That is, if we can maximize the function with respect to lambda, when we find the lambda simultaneously, we also find the x star for minimization. 可以吗？我再说一次，就是这非常有趣的一个现象，就是当你有了 constraint 的时候，整个 function 就变成所谓的 Lagrange function。那虽然我们原本是要找就是x star，OK， 就是变动 x 的时候，在 x star 那一点 function 值会最小，但是其实等同于你如果也可以找到，就是当你变动 lambda 的时候，找到某一点 lambda star， 它的 function 值是最大的时候，同时你也等于也解了原本的问题。OK， Yep. So this is the so-called duality theorem and saddle point theorem. Let me just quickly give you guys an example. Oh, and by the way, some theories will be explained in more detail next time. OK。的一些比较理论的东西，理论的一些说明，我想下礼拜再说。我们今天先多给大家几个例子。OK。Yep. Okay. So let's see. Oh, but first of all, I need to tell you. Yeah, I need to give you guys the definition of some terminologies. Okay. So the so-called primal problem. And you can just think of this as the original problem. Okay. Okay, so primal problem is basically the original problem. So what is the original problem? Over here, yeah, it's very clear that the original problem is to find x, a set of variables, xn, to minimize f of x subject to some constraints, right? Okay, and here j from 1 up to n. So that's the so-called primal problem or the original problem. Okay, but over here we also have the dual problem. Okay, so the dual problem is basically like that. Yeah, we want to find a set of variables, lambda, right? So lambda is from lambda 1 up to lambda m. Lambda 1, lambda 2, up to lambda m. Yeah. To maximize the function h of lambda. Okay. And what is h of lambda? It is actually obtained by finding x which minimizes the Lagrange function. Okay, L equals f of x plus the summation of lambda jhj of lambda jgj. Okay, yep. Okay, so I guess you still don't understand what's going on, but let me quickly give you guys an example, and hopefully you will be able to, at least you will be able to apply this kind of theory. Okay. So one more time, the so-called primal problem is the original problem, and the dual problem is to first you transform. First you have the Lagrange function, okay, and then you try to minimize the function by varying x, and after doing that you will be able to have a function that is called h of lambda, and then you just need to maximize h of lambda, and that's it. Okay. Yeah. 可以吗？这看起来好像蛮有趣的，对不对？因为你就不用一个一个去 check， 你解出来之后你不用去 check， 因为当它这样，它自然可以满足那些 constraint. Okay. So let's just quickly give you an example. Yeah, let's just use this simple example. So let's say we want to minimize f, and let's say we have only two variables, okay? x1 squared plus x2 squared. Oh, 2x2 squared, okay? Subject to the constraint x1 plus x2 is greater than 1. Okay. Oh, but I think it's better to use the standard format, okay? So let's just say it's g x1 x2 equals 1 minus x1 minus x2, right? So g is less than 0, okay? So this is the problem. And let's try to solve this problem using the duality theorem and the duality and saddle point theorem. Okay. First of all, we need to define the Lagrange function. L is f plus lambda g. There is only one constraint, so just lambda g. Okay. Okay, so that's my Lagrange function. Okay. And then, let's find h of lambda. So h of lambda is obtained by finding x which minimizes L. Okay. So this means that we can use the necessary conditions. So let's use the necessary conditions. Let's take partial derivative with respect to x1 and x2. Okay, 2x1 minus lambda, and set that to be 0. And 4x2 minus lambda, okay, and set that to be 0. Okay, so in this case, x1 star can be solved. That is half lambda, right? And over here, x2 star can be solved. That is 1/4 of lambda. Okay. And if you plug this back in the Lagrange function, you can get h. So in this way, h of lambda is found by plugging x1 star and x2 star, right? Because right now it's a function of lambda, okay? Okay. So okay, yep. So what is this? Yeah, let me just simplify this, and finally you have this lambda squared, okay, plus lambda. Okay. Oh, and by the way, over here, after having this, yeah, you know, the necessary condition does not guarantee that here we have a minimum. But if you take a look at the Hessian matrix, you will see that yes, the Hessian matrix is positive definite. So over here, indeed, we have a local minimum over here. But anyways, what we do here is to find a way to express x1 and x2 in terms of lambda, because what we want is to transform L such that L becomes a function of lambda, and we call this h of lambda. Okay. Now, let me just do this h of lambda. Right now, there's only one constraint. Okay, so h of lambda equals L of x star lambda. Okay, so this is what I mean. Okay, 反正就是把刚才得到的 x1 x2 带到原本的 L， 好，得到一个 lambda function. Okay, and then what do we do? Yeah, and then we just want to maximize h of lambda. Okay, so then we maximize h of lambda, and again we try to use the necessary condition. Okay, yeah, because right now there's only one variable lambda, so dh d lambda is what? dh d lambda is -3/4 lambda plus 1. Okay, and set it to be 0, right? Set it to be 0. So in this way, lambda star is found to be what? Yeah. Okay. And if you take second order derivative, you will see that we have -3 divided by 4, and which means that yes, the point we have found is certainly a local maximum, right? 就当你2次微分，把 h 对 lambda 做第2次微分，发现它是一个负的数，那代表什么？在那边应该是 local maximum, right? Okay. So, anyways, yeah, that's right. Okay, so lambda star is a local. At lambda star, we have a local maximum. Okay, but anyways, in this way, when lambda star is calculated, what is x? So x1 is what? So finally, my solution is like this: 1/2 of lambda star, okay, is what? And x2 star is 1/4 of that. That's it. So as you can see, we do not need to check whether the constraints are violated or not. By using this duality theorem or saddle point theorem, we are able to transform this into a maximization problem, and then finally, yeah, that's it. Okay, so this is the solution. Okay. Of course, if you want, you can use the KKT conditions to solve the same problem, and you will see that we get the same answer. Okay. So today, because homework 1 has been assigned. I hope that you guys have the ability to solve all kinds of problems, and that's why today I use a lot of examples and I introduce several methods to solve like constraint, optimization with equality constraints and also optimization with inequality constraints. Okay, I will talk more about like the reasons next week. 可以吗？这是它一些背后的一些理论，我下礼拜再说。但今天先给大家例子，让大家可以做作业。Okay, so that's it for today. Okay, thank you. And please check in online by yourself. Okay. Oh, and I still think I need to take a photo.